So today I'm going to be talking about an introduction to exponent laws. In a previous video, I focused on the division rule and on the multiplication rule, and so that might be helpful for you if you're starting out. This is going to be a little bit of a deeper dive into the following three rules: the power of a power rule, power of a product rule, and finally power of a quotient rule. So just diving right into it. For starters, the power of a power rule can be represented by this following equation. So if you have a base a, and this is raised to a certain exponent, we're just calling this m. And then this, power, a raised to the exponent m, serves as a base for another exponent, n. In this case, you can think of just multiplying in m and n. And then you're going to end up with that original base a raised to the exponent of m times n. For the power of a product rule, you're going to have a base that's comprised of two sections. That's how I like to think of it, each multiplied by the other. So here we have two variables. A is multiplied by b, and this creates the base in this equation. This is then raised to an exponent that we're just calling m. What we can do here is we can separate these two parts of the base, and we can multiply. I like to think of sort of dispersing the exponent. It's not an actual act of multiplication, but that's just how I like to sort of think of giving this to the different parts of the bases. Hopefully that makes sense. And then you can write that as one section of the base raised to that same exponent multiplied by the other section of the base raised to that same exponent. The quotient rule is very similar to this. So you will have two sort of segments that create this base. So here in this case we have a divided by b, and they're divided by each other instead of multiplied. That's the only difference here. And this is raised to an exponent n. And again, you can sort of think of it as dispersing the exponent to the different parts of that equation. And then here we have a raised to the exponent n divided by b raised to the exponent n. A major difference here is that b cannot be equal to 0. So if you have any number over 0, then it's just not feasible. So this is especially important in the power of a quotient rule. In addition, you may have noticed I have these little caveats written here under each rule, and this is just to emphasize that these things must be true. So a and b are any integer except for 0, and m is a whole number. So these are the exponents. So basically, n here has to be a whole number, so that's the exponent. In this case, with the power of a product rule, m, which is the variable designated for that exponent, it has to be a whole number as well. And here again, the exponents m and n both have to be whole numbers. In addition, the bases in these equations, so whether that's a in the power of a power rule, it has to be an integer except for 0. A and b are again integers except for 0, and a and b in this final equation are integers except for 0, which has an added layer of importance because b cannot be equal to 0 in a quotient. So now we're going to go into some practice problems. The first problem section talks about simplifying and writing as a power. And if we look carefully at these three questions that we've been given, we can see that we need to apply the power of a power rule. This is because we have a base raised to an exponent, and this serves as another base for another exponent. If we look carefully, we can see this applied. We have a base of -4 raised to the exponent of 2, and this serves as a base for the exponent of 3. Therefore, we can write this as -4 as the base, and then multiply the exponents 2 and 3. If we simplify this, we get -4 raised to the exponent 6. Notice how I included the negative sign? I did this because that's part of the base. So here, we can see that we have a base of 3 raised to the exponent 5, and this as a whole serves as a base for another exponent of 5. This means we can take that original base of 3 and then multiply the two exponents. This gives us a simplified power of negative 3 raised to the exponent 25. And notice how the negative is not included within the brackets because it's not influenced by the exponent. Finally, here we have our original base of 2 raised to the exponent of 3, and this serves as a base again for the exponent of 2. Therefore, we can write this as 2 raised to the exponent of 2 times 3. When we simplify, we get 2 raised to the exponent of 6. Moving on, we have our second set of problems. So simplify powers of products. This tells us directly that we're looking at power of product problems. We can see this because we have two numbers that are multiplied by each other to create a base. So here we have 4 times 2, and this serves as the base, and the exponent is 2. If we think back to our rule, what it basically says is that we can apply that exponent to the individual parts of that multiplication. So if we do that, this is what it looks like. There we go. You could write brackets instead, but I think I'll just leave it like this. How about here? Same thing. So let's write that 3 raised to the power of 3, or then same thing. So we're applying that exponent to the different parts of that base. And finally, over here, let's see. We have negative 1 raised to the exponent 2 times 2 raised to the exponent 2. Only here, with our negative signs, we need to be a bit careful. So I'm making another bracket here just to show that this multiplication or this negative sign is multiplied by this whole chunk here. Same thing over here. So we just add brackets here to show that the negative sign is multiplied in to whatever number we get here. Finally, our last set of problems, simplify powers of quotients. So let's return to our quotient rule. Basically, we are taking that exponent and we can write it on the individual parts of that quotient. All right, 4 raised to the exponent 2 over 1 raised to the exponent 2. 5 raised to the exponent 0 over 3 raised to the exponent 0. All right, and now we can solve this if we'd like. 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. 8 over 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Four times 4 is 16 over 1 times 1, which is 1. And here, remember our previous law that anything raised to the exponent 0 is equal to 1. So here we have 1 over 1, or simply 1. All right, so that was our lesson on Introduction to Exponent Laws with a few examples.